Vegan, the best life change.
Our programs offer many languages. Please visit suprememastertv.com/schedule.
Nos programmes offrent plusieurs langues. Veuillez visiter suprememastertv.com/schedule.
Nuestros programas ofrecen varios idiomas. Visite suprememastertv.com/schedule.
Nuestros programas ofrecen varios idiomas. Acesse suprememastertv.com/schedule.
Did you know that the vibrant array of colorful feathers birds have is actually derived from the fruits and seeds they eat, as well as refractions of light shining through their feathers? Continue watching to find out more.
Hola, bendecidos e iluminados televidentes. This means hello, blessed and enlightened viewers, in Spanish, the official and most spoken language in the Republic of Guatemala.
I am Santiago, a male painted bunting, and this is Valentina, a female painted bunting. We are both vegans from marvelous Guatemala. May your bright, compassionate, and healthy vegan lifestyle add more colors and vitality to your life.
Welcome to the Secrets to Birds Vibrant Plumage Coloration, Part 1 of 2.
We belong to the family of passerine birds, who are renowned for the striking colors the males display on their plumage. Indeed, their plumage is so colorful it is like a kaleidoscope. Many people consider us one of the most beautiful birds in North America. Therefore, we have a nickname, non pareil in French, which means without equal. In Mexico, we are commonly known as siete colores, meaning 7 colors. According to a Native American legend, the Great Spirit, while adorning the birds with colors, happened to run out of pigment, so he dubbed us the very last species left with touches of whatever colors remained. In this series, we will explore why and how we have such colorful feathers. Santiago, could you please tell us more about the dazzling colors in your plumage?
My pleasure. The great English poet Leigh Hunt said, "Colors are the smiles of nature." We birds have nature's most cheerful smile, don't we? Our feathers derive their color from pigmentation, the refraction of light through our feathers, or from a combination of both.
So, what generates the red found on your breast and rump?
In my case, the red plumage is the result of both pigmentation and my feathers' structure.
Carotenoids, melanin, and porphyrins are the 3 substances we metabolize into the 3 pigments found in a bird's feather palette. Red, orange, and yellow feathers come from the carotenoids we absorb through what we eat, since our bodies cannot synthesize them.
Humans too derive beta-carotene from fruits and vegetables.
Exactly! Fruits and seeds contain various amounts of carotenoids.
For example, the male northern cardinals obtain their signature bright red plumage mainly from dogwood berries, their favorite food, which are rich in red carotenoids.
Should these berries be in short supply, these birds will gradually lose their brilliant color.
On the other hand, the feathers of the Baltimore Orioles can turn even redder than normal when they eat red honeysuckle berries while molting.
Interesting. Then how about those dabs of brown color on your wings?
Melanin displays as black, brown, gray, or earth tone colors in our feathers. This is the same pigment that determines the hair and skin color of humans. While the colors that melanin produces are not as bright as carotenoids, the majority of our complex plumage patterns actually come from melanin, because unlike carotenoids, melanin can be synthesized in our bodies. The white-breasted nuthatch's cap and nape are black due to high levels of melanin. If a bird sports gray and black stripes on their wings, or white on their breast and throat, this means that they synthesize less melanin.
Cool! In other words, God would fill brushes with carotenoids to boldly paint our plumage with bright colors and reserve melanin for fine details, and to design intricate patterns.
Well said, Valentina. Melanin not only colors our feathers, but also reinforces their strength and resistance to abrasion. That's why many seabird species, especially the ones which migrate long distances, have black wing tips or black primary feathers. The northern gannet, herring gull, and snow goose have such feathers which are built to sustain the wear and tear of extensive travels.
Wow, I didn't know this before. And which colors do porphyrins generate?
The vibrant hues of pinks, reds, browns, and greens noted on the plumage of owls, peacocks, and pigeons are derived from porphyrins. The turacos, for example, owe the unique brilliance of their red and green plumage to the type of porphyrins synthesized in their body.
Awesome! I have heard that parrots hold a patent for exclusive pigments.
Right. Parrots synthesize special red, orange, and yellow pigments called psittacopholdins that are not found in other birds or plants. As a result, the brightness of their feathers is not affected by their diet. Scientists have found that the color of psittacopholdins is determined by the precise arrangement and concentration of its molecules. In fact, while growing feathers, parrots monitor the release, sequencing, and concentration of psittacopholdin molecules to produce the splendid colors in their plumage. Parrots are truly blessed with amazing artistry, and not only that, psittacopholdins also appear to protect the feathers from harmful bacteria.
It's time now for us to peck away at some simple yet satisfying vegan food. We will pause for a brief constructive message and return. Please stay tuned to Supreme Master Television.
Vegan. Sounds like heaven.
Welcome back to the Secrets to Birds Vibrant Plumage Coloration, Part 1 of 2 on Supreme Master Television.
Santiago, what makes your head blue and your back green? You have not mentioned it yet.
You are a keen observer, Señorita Valentina. No bird species can synthesize the color blue from pigments. Blue pigments, as found in blueberries for example, are destroyed by the digestion process. When white light strikes a blue feather, the nanostructures comprised of keratin protein and tiny air pockets in the barbs of the feather reflect blue light, and the layer of melanin pigment absorbs the remaining colors. Tiny differences in the structural composition of keratin and air pockets will thus produce different shades of blue.
Oh, I see. It is similar to what makes the sky blue, air molecules that scatter blue light.
That's spot on! What a smart señorita! The nanostructures in the blue feathers reflect blue light rays in an orderly way, in which they reinforce each other. If we were to shine white light from behind a blue feather of a male indigo bunting, it will appear brown-black due to the melanin in it. Meanwhile, its green feathers are colored by the combination of the blue light reflected by its structural composition and the yellow color of its carotenoid pigment.
Amazing! Now I know what produces your blue and green colors. How about the shimmering rainbow colors of male hummingbirds' throat feathers? Would their colors change if we looked at them from different angles?
The patches of color on the throat or upper breast of male hummingbirds are called gorgets. This word was also historically used to describe a piece of linen wrapped around a woman's throat or head, and piece of armor a medieval knight wore to protect his throat. The microscopic structure of the barbels of iridescent feathers under gorgets consists of microscopic structures of melanin called melanosomes, which are similar in shape to flat pancakes and are stacked neatly in 7 to 15 rows. It is this special arrangement of layers, combined with pockets of air between them, which give the hummingbirds their famous iridescent colors. Melanosums work like a prism, bending different colors of light by different angles, thus causing the feathers to appear to shimmer as they move.
It reminds me of little rainbows dancing in soap bubbles.
Correct. Light is split into its different colors and then reflected to the viewer just like it is from the soap bubbles and also from raindrops when they make a beautiful rainbow. Other birds are also adorned with an iridescent plumage, including mallards, but the feathers on mallards' heads don't shimmer as brightly as those on hummingbirds' gorget because the melanosomes in them are shaped more like tubes than pancakes, and because they don't have as many air bubbles in them.
Truly fascinating. Now I'd really like to know how the actual colors are determined.
Oh, you found something? Let's have a look.
Yes, it's a complex matter, but I have just found a little bit more about the coloration of Gaudian finches, a gorgeous species from Australia, whose heads are commonly colored in red, black, and yellow. To be endowed with a black head, the males require 2 black genes on the chromosomes that also determine their gender, while the females require only 1 gene to direct melanin deposits to the feathers on their head. For a head to be colored red, males and females need just 1 red gene on their sex chromosomes, as the red gene is dominant to the black gene. For yellow, a yellow and red gene are both required, but more research is still needed to fully understand what makes that particular color appear in the bird's feathers.
Wow! The science behind the coloring of the plumage of birds is quite complicated. There is certainly lots to learn.
Yes, something as simple as our vibrant colors is actually quite complex, but as more and more research unfolds, humans will understand more and more about our dazzling colors the Creator has blessed us with. Let us also continue to enrich nature and brighten our fellow co-inhabitants with the beauty of our dazzling plumage.
Certainly! Next week, we will share why we birds develop kaleidoscopic colors in our plumage. Please tune in next Friday, July 23rd for The Secrets to Birds, Vibrant Plumage Coloration, Part 2 of 2.
Gentle viewers, we appreciate your company for today's program. Up next is Make Miracles with Your Positive Spirit, Part 6 of 6 on Between Master and Disciples, right after noteworthy news. May the beautiful colors of nature enrich your life.
Our programs offer many languages. Please visit suprememastertv.com/schedule and suprememastertv.com/AW.
Vegan, for the change we've been awaiting.